Hi everyone. Let us just get started with one of the very popular method which is called tree method. Okay, so in this video we are going to study something called tree method. But before that there is just one simple implication of the probability definition, conditional probability definition, which is multiplication rule. So let's just see this multiplication rule and then we will see tree method, which is very popular. So multiplication rule is very simple. If you remember the conditional probability definition, which looks like this: probability of A given B is actually probability of A intersection B upon probability of B, right? So you can rewrite this as probability of A intersection B equal to probability of A given B into probability of B. So something like this, right? Probability of B into probability of A given B. Or maybe if you want, you can write probability of B given A as probability of A intersection B divided by probability of A. So from here also you can write the formula of probability of A intersection B as probability of B given A into probability of A. So you can write either like this or like this, right? So this is called multiplication rule. So what I'm saying here is that, see, first of all, like either I write this intersection or I write this comma, both are actually same. Actually, these are the different notations that people use. Some people like to write this intersection, some people like to write this comma. In fact, when we go to random variables, at that time, I will not be using this intersection. The popular notation there at the random variable is actually comma. Okay, I will tell you that later. Actually, in some of the textbook also, they avoid writing the intersection and comma also. They just write like this, which means they say that okay, this notation, this notation, and this notation, these all notations are same. So notation wise, these are just notation. Notation wise, these are all same. Okay, so these are different notations. Mostly I will be using this. Okay, mostly I will be using comma. I hope that is fine to everyone. So now let's just talk about this multiplication rule, which is probability of A intersection B or probability of A comma B or B comma A, does not matter. That is actually equal to probability of. Now what you can do, like I'm just asking you to just like asking you to remember one of the way to write this formula is like that. You just start from either of end. Either you start from the right hand or you start from the left hand. So just do one of the thing. Okay, let's just start from the right hand. So just write probability of B into now probability of A. Okay, now probability of A. But already happening is basically B, which means probability of B into probability of A given B. Now similarly, what you can do, you can start from the left hand, or maybe just for the consistency, we will always be starting from the right hand. So either you write A comma B or you write B comma A. First of all, both are same because both are A intersection B only. Now what you can do is start from the right hand always. Okay, it will be probability of A into probability of B. But since A has already happened, like this, you can remember that given A. Okay. Now what we can do, we can actually extend this to multiple I can say variables or multiple multiple events basically, right? Like instead of just having these two events A and B, I can just extend that to multiple events, which is A, B and C. So let me just try doing it. So suppose you have three events, which is A, B, C. Okay, so probability of A intersection B intersection C. If someone asks you something like this, I mean that's exactly same way of writing A comma B comma C, right? Now what you can do, you just start from the right hand. Just remember to start from the right hand. So it will be probability of C into probability of B given what is already happened, C into probability of A given B comma C or B intersection C. It does not matter. Okay. So suppose if I say that probability of A comma B comma C is equal to which of the following? Suppose if I ask you this question, which of the following, then let me just see if you can answer this question. Okay, so let's suppose the first option is probability of C into probability of B given C into probability of A given BC. This is the first option. Second option, let's suppose it is probability of A into probability of A given B into probability of A given probability of B given A, probability of B given A into probability of C given A comma B. Let's suppose this is another option. Suppose there is one more option which is saying probability of B into probability of maybe anything, maybe C or A, does not matter, A given B into probability of C given A comma B. Let's suppose maybe there is one more option, probability of B into, let's suppose there are multiple options. Okay, there are actually many options possible. Probability of B, then probability of C given B, then probability of A given BC, something like this, right? So suppose there are multiple options. These are the 4 options that you have, and this is the MSQ question. Now can you solve this question? Can you let me know that which one of the following is true? Just think about it. See what I just told you in earlier slide. Okay, so this is the earlier slide. In this earlier slide, what I just told you, that you start from the right hand only. Okay, I mean you can start from the left hand also, but just be consistent. Just start from the right hand, and then this probability into probability of B, right? Probability of B given what has already happened into probability of A given that this BC, right? Now let's just see that if you want to write something like that, then can you start from this like ABC? Can you start from the right hand? Yes, C, and then B given C, and then A given BC. So I think this option is very much correct. Well, let's just see that if this option is also correct, which means this B option is also correct or not. So for that, what you can do, let me just try doing it in the next page. What you can do, you can say that okay, you want to write this ABC as maybe like instead of writing this ABC, maybe you can write from the right hand, which means you can write in this order: A, B, and then C. Maybe let me just try it. Maybe you can write like this: A, B, and C, right? So if you write this in terms of this factorization, actually it is called factorization. You are factoring out the joint probability distribution. Anyway, like these terms are not important for the gate purpose, but yeah, it is called joint probability distribution, and this particular process that what we are doing today is called factorization of this joint probability distribution. But yeah, like we will just call it multiplication rule, because for gate purpose we don't need beyond maybe 2, at max we need 3. But if you have n such events, then it is basically generally like general term is called the factorization of this joint probability distribution. Anyway, these terms are not required. Okay, so let me just factor it. So what you will be doing, you will be first going to this A. You will say that okay, this is the probability of A multiplied by probability of B given A multiplied by probability of C given A comma B, right? So yeah, that is why this B option is also correct. Because see, what they're asking here is that which of the following option is as good as this particular probability, and this thing is as good as like whatever we have just written. These two are actually same, right? Because this commas are just intersection, and you can actually rewrite the commas, which means like you can write either ABC or any other permutation of ABC, which is CBA, BCA, or whatever you want to write, right? So you can definitely write it like BC, like CBA, and then you can factor it out. So if you do so, then B is the correct answer here. Now let me just try doing for the C. C option is saying that B should be first, and then I think A should be next, and then I think C should be next, right? So CAB, let's just factor out the CAB, and let's just see if we are getting this particular option. So probability of B, yes, you are getting, and then probability of A given B, yes, you are getting, and then probability of C given AB, yes. So that's why this option is also correct. And now similarly, let's just check whether this option D is also correct or not. So for option D, this is for option C, this is for option D. For option D, what you're doing, you can write this B at the end, maybe, and then C, and then A, right? So you can write probability of B into probability of C given B into probability of A given CB or BC, right? So I think yes, that is also correct. So that is why all the options are correct here. So this is just a one nice MSQ, you can say, where I just wanted to check that check whether you can actually factor out the given probability distribution or not. Okay, so whether it is just two events or maybe 3 events or maybe just 4 events, like you can actually do this particular method to any number of events. So let me just for the sake of completion, let me just try doing it for the 4 events. Suppose these are the 4 events. So what you will do, you can write it as probability of D into probability of C given D into probability of B given CD into probability of A given BCD. So actually you can write like this, and maybe some other permutation also you can write, and then you can rewrite like this. Although these things are not required for gate, so let's just end this discussion here. What I wanted to convey in this particular concept is that if you have any multiplication rule, or if you have two events at least, then you can rewrite it like this. Okay, for the 2 events I think this is fine. Even for the 3 events now I think it should be fine, or maybe for the 4 events, but we won't be requiring it for the gate. In this particular video, I wanted to convey one very nice method which is called tree diagram. So let's just directly jump to the tree diagram, which is very useful for the conditional probability. It is so useful that you can solve almost all of the gate previous year questions just using the tree diagram if that's related to conditional probability. Okay, so most of the conditional probability question that we will also solve in the videos of gate PYQs or any other normal conditional probability question can be solved using this tree diagram. So it is very handy because it is some method which is actually enabling you to visualize the things, right? So very handy and very nice method. Let's just jump into this. What is this tree diagram? So tree diagram is actually useful in the sequential models. What do I mean by sequential model is that you have any sequence of events, which means, let's suppose if I say that you are tossing a coin 3 times, then you will say that okay, this is a sequence, the first time, second time and third time. This is a sequence. Observing the value of a stock on 5 consecutive days or 5 successive days, that is also a sequence. Why? Because the first day what was the value of a stock, second day what was the value of a stock, like that. I mean, you are basically making a sequence out of it. Receiving 8 successive digits at a communication receiver, so which means like I mean, if order matters basically, right? If order matters or the sequence matters, then you can apply this tree diagram. So let me just tell you that how it is useful. Maybe after the examples you will be more comfortable with that. So let's consider a tree diagram with very simple example for the coin toss. Suppose you are tossing a coin, then there are two outcomes possible. Either head will come or the tail will come. Now the probability of head, let's suppose probability of head is, let's suppose 0.5, and probability of tail is, let's suppose again 0.5. So in that case you will make a tree diagram where you will say that okay, if head comes with the probability, then the probability is 0.5. If tail comes, then probability is 0.5. See here, I'm not conducting this experiment again and again, which means like I'm just tossing one time. What if you toss it multiple times? Then you will be having a branch of this tree. Let me just show you how. So suppose you toss it 2 times, okay? Tossing a coin twice. Let's suppose you toss it 2 times. In that case, in the first flip, you will say that okay, if head comes or tail comes. If head comes, then in the second flip, head may come, tail may come. If the tail comes, then in the second flip, head may come and tail may come. So basically, there are total 4 outcomes. And now it is basically a tree diagram which is representing the flips. This is the first flip and this is the second flip. Now let's just see more examples, and then we will be doing the questions. After that we will be doing all of the gate previous year questions just using this tree diagram, and then you will be more comfortable with this tree diagram. Okay, so let's just directly jump into the first question, and then we will be solving this conditional probabilities question using the tree diagram. So what this question is saying is that they are saying that suppose that you are playing soccer game and you love to become a goalkeeper in that game, but that depends on the coach today. Which means if coach is same, then you can be goalkeeper with the probability 0.5. If the coach is Alex, then you can be goalkeeper with the probability 0.3. So basically, you want to be goalkeeper, but it will depend on the coach. If coach is same, then you can be goalkeeper with the probability 0.5. If coach is Alex, then you can be goalkeeper with the probability 0.3. And the probability of Sam being coach is 0.6. Now what they're asking is that what is the probability that you will be goalkeeper today? See, here there are two events. One is that you are going to be goalkeeper, and another one is that who is going to be coach. Now, just think with your common sense that which event is more likely to happen first. Whether you will be choosing goalkeeper first or the coach will choose you goalkeeper. I mean, first the coach will get decided, and once the coach is decided, then you will be decided whether you will be goalkeeper or not, right? So if I just talk in terms of common sense, then you will say the sequence of events here is that first coach and then goalkeeper, isn't it? Very naturally it is coming. See, first you need to decide who is the coach, and then once you decide that who is the coach, then you need to decide who is the goalkeeper, whether you will be goalkeeper or not. So very naturally you can easily find out the sequence of events. Okay, so here you will say that there are two events. One is coach, another one is goalkeeper. So first let's just choose that which one is coach. Coach may be Sam, coach may be Alex. And what are the probabilities? Probability here for choosing Sam is 0.6, then for choosing Alex it will be 0.4. Okay, if Sam is the coach, then you may be goalkeeper or maybe no goalkeeper, right? You may be goalkeeper, you may not be goalkeeper. And the probability with the Sam is 0.5 and 0.5. With the Alex, the probability goalkeeper and no goalkeeper. With the Alex, the probability is goalkeeper probability 0.3, which means the not goalkeeper probability 0.7. So this is the simple tree diagram that you can have, right? See, once you're choosing Sam, once you choose coach, and then you will be choosing whether you will be goalkeeper or not. Very easy tree diagram. Now let's just see the tree diagram. See, once you choose Sam or Alex, and then once you choose whether it is Sam or Alex, then with the Sam 0.5 probability, with the Alex 0.3 and 0.7 probability. So that's how you get the tree diagram. Or maybe I can just expand this tree diagram here itself. It is 0.5, 0.5, it is 0.3 and 0.7. it is basically saying goalkeeper, it is no goalkeeper, it is goalkeeper, no goalkeeper, right? Great. Now once you make this tree diagram, can you just answer some of the questions that is asked in the question? So the question is saying what is the probability that you will be goalkeeper today? Which means they are asking what is the probability that you will be goalkeeper. You can be goalkeeper here, you can be goalkeeper here. So here, if they are asking this probability, what you can do, you can add all of these nodes which are having the goalkeeper. So see, let me just write down few of the probabilities and then I will tell you the very nice interpretation of this tree method. Okay, so let me just write one probability here, 0.6 into 0.5. Can you just guess that what is this probability? Just guess it. This is the probability of you being coach, you being goalkeeper, given that Sam is already coach. Not given that, I mean first the Sam is chosen to be coach. So basically this is the probability of Sam being coach and you being goalkeeper, right? So this is the probability. Basically it is 0.6 into 0.5. This is the probability that both of the events, Sam and goalkeeper, happen at the same time. Now this is the probability that both of the events, whether Alex is coach and you are a goalkeeper, with this probability you will be goalkeeper with if Alex is coach. Okay, with Alex you will be having this probability to be a goalkeeper. So technically, let me just represent these probabilities. Technically, this particular node is representing a probability of goal and Alex, which is 0.3 into 0.4. Technically, this probability is basically Sam comma Alex, Sam comma goalkeeper. This probability is basically probability of Alex comma not goalkeeper. This is basically the probability of the node probabilities. Okay, the node probabilities are actually the multiplication probabilities in the tree diagram. This is the probability of Sam comma non goalkeeper. Okay, and these edges probabilities are also very nice. These edges probabilities are conditional probabilities. Okay, so what do I mean by that? This 0.5 is the probability that you are the goalkeeper, so it is a conditional probability given that the earlier thing will be given that Sam is being coached. Okay, so if Sam is coach, then you are a goalkeeper. This is the probability. If Alex is coach, this thing is always given. The left hand side is always given. If Alex is coach, then you are not goalkeeper. The probability will be 0.7. So the edge probabilities will be the conditional probabilities and node probabilities will be the multiplication probabilities. That's how this tree diagram works. Okay, so let me just tell you in the abstract way what do I mean by that. Suppose there are two events, either A happens or B happens. Okay, or maybe A happens or A complement happens, maybe because A and B, let's suppose, are complement to each other because these are just two events. Or maybe A and B, let me just write A and B, and then let me probably say that C happens or C does not happen. Okay, and D happens, or maybe C just C happens or C does not happen. Let's suppose this is how I'm making my tree diagram. Now, can you tell me which probability I will be writing here? I will be writing probability of happening C given that A has already happened. What is the probability I will be writing here? I will be writing probability of A comma C, right? So these are the node probabilities, which are the multiplication probabilities. The edges probabilities are basically conditional probabilities. What is the probability I will be writing here? The probability of nothing has happened. See, initially nothing has happened. Probability of A and nothing has happened. So it is actually like simplify. Like if I do the simplification, it is just probability of A. I mean, this is also a conditional probability, but conditional on nothing. So that's why you are just writing as a marginal probability. Okay, this is the probability of B. And this is, can you just guess it? This is probability of C complement given that B has already happened. And what is this probability? This is the node probability, which is probability of C complement given that, not given, like intersection with B has already happened. The happening of this C complement and B together. Now let's just see whether all of this picture mathematically make any sense or not. Which means, can we mathematically justify this picture? Let's just try seeing it. So this node probability is actually the probability of, the way I will be calculating this node probability is actually, I will be just multiplying all of these edge probabilities. So what is this edge probability? Probability of A into the next edge probability is probability of C given A. Should it be probability of A comma C? With the multiplication rule, you can easily see that yes, that is true, right? So the way it is designed is very beautiful. See, ultimately you are following the mathematics rule only, but with very convenience. Now this tree diagram and the whatever we have seen in the conditional probability definition or the multiplication rule, this tree diagram is just a visual representation of all of this. Okay, so whatever we are doing in this tree diagram is exactly same as what we have already done, but it is just for our convenience we will be making a tree. Okay, so that we can understand the questions very easily, we can answer them very easily. Now let's come back to this particular question that we were solving here. Now if I just ask you what is the probability, okay, what was the question, what is the probability you being the goalkeeper today? So if they ask you what is the probability you being a goalkeeper, so just mark all the nodes which are having the goalkeeper and add all the probabilities. So it will be 0.6 into 0.5 plus 0.4 into 0.3, right? It will be like that, 0.6 into 0.5 plus 0.4 into 0.3, right? So this is probability of you being goalkeeper. Now do you want to also see this mathematically, which means that do you want to check whether it is mathematically justified or not? Let's just see it. Okay, so let's just see whatever we are writing, it is not just a guess, it is actually mathematically backed up. So maybe I can do one thing, I can just minimize this, right? Okay, can put it here, and let's just see that whether this is mathematically justified or not. So for that what we can do, actually you don't need to do again and again, but I am just doing it. Probability of goalkeeper should be, I am just saying that you add both of this. What is this mathematically? This is basically probability of this node, probability is basically probability of Sam comma goal plus probability of LX comma goal, right? So isn't it okay to write something like this, which means probability of goal is actually equal to probability of Sam comma goal, like you being a goalkeeper, plus probability of Alex and you being a goalkeeper. Actually it is same. Now how to justify it at this point in time, let me just think about it. Actually there is one rule that is called divide and conquer, or the total probability rule. Okay, maybe we can talk about it later. So this is actually justified using a total probability rule, that we might see later, but let me just think if we can do today, I mean we can do in this something in this video or not, or maybe we can just see this later using the total probability rule also, right? Cool. So let's just do one thing, we will just prove this, that this is actually true using the total probability rule later. Okay, so now if they ask you what is the probability of being goalkeeper, then you can just add all of these nodes, and which is basically 0.6 into 0.5 plus 0.4 into 0.3. Now let's just do more questions and let's make sure this tree diagram is very clear. If you're afraid with this tree diagram just with one example, then your interpretation is actually wrong, because you are going to love this. Okay, so let me just go through more examples. Let's just see this example. Now what this example is saying, on a Sunday evening 50% people watch a movie, 30% people watch a cricket match, and 20% people watch comedy shows. So basically there are a division is like this, 50% people watch movie, 30% people watch cricket, and 20% people watch comedy show, right? Cool. Now the percentage of people skipping ads are 20%, 25% and 15% respectively, which means if they are watching movie, okay, 50% of people watching movie and then they skip the ad, is basically the probability is that or the percentage that 20% with the 20% ratio they will be skipping the ad if they are watching the movie. If they are watching cricket match, then 25% they will chances are there they will skip the ad, and if they are watching the comedy, then 15% chances that is there they will skip the ad. Now they've asked something, but before that, can you make a tree diagram? First tell me, first you will be skipping the ad or you will be watching some show, movie, cricket or comedy? Just think it naturally. First, can you skip the ad without watching something? Obviously no, right? So the natural sequence of event you need to find out, which is basically first you need to pick one of them, whether you are watching movie, whether you are watching cricket match, or whether you are watching comedy. Then you will go to the next sequence of event, which is skipping the ad. So let's just start with very first event, which is watching the show. So it could be movie, right? It could be cricket, or it could be comedy. There are three options which is given in this question. Now the percentage and probabilities are same, so you can say with 0.5 probability you will be watching, or someone will be watching movie. With 0.3 probability someone will be watching cricket match. With 0.2 probability someone will be watching comedy, right? So these are the probabilities. Now with this movie, they are saying 20% are chances, which means 0.2 is probability that you will be skipping add, and obviously 0.8 is the probability that you will not skip add, right? No skip add, not skip add, or something like this. Okay. Now similarly, you can just extend this diagram probably. Let me just try doing it. Okay, so let's just bring this diagram here, and it will be a little lengthy diagram, but yeah, that is fine. So now from here you can say that there are 25% chances, so 0.25% chances are there, skip add or not skip add, right? Similarly here also you can say 15% chances, right? 0.15 skip add and 0.85 not skip add. So that's how you can make a tree diagram. Now let's just answer whatever they've asked to us. So what they've asked is basically probability of watch cricket and see ad, right? So watching cricket and see ad, which means, and they are asking the intersection probability, which means they are asking the node probability. Watching cricket and seeing ad. Okay, seeing ad not skip ad, right? So this is 0.75. So you can just multiply both of this. You can just say that, okay, this is probability of watching cricket and see ad is actually 0.3 into 0.75. That's all. That's how easily you can answer this question. Now if I just ask you what is the probability of seeing ad, then you need to add some of the probability. See, you need to add this node probability, which is 0.5 into 0.8. You need to add this node probability, which is basically 0.3 into 0.75. You need to add this node probability, which is basically 0.2 into 0.85. So basically you need to add all of these probability, and then finally you will be getting answer for the skipping ad. So that's how you can get the answer for different questions. But in this particular question, they have just asked for the watch cricket and seeing ad. So yeah, this is the answer, right? And if they just ask you the probability of just seeing the ad, then you need to add all of these node probabilities, right? Cool. So see here, like the answer is 0.225, and that's how we can calculate the answer. I hope you understood this question. Very nice, elegant and easy question, right? See, from these questions you will learn this probability method. You will learn this tree method, and once you learn this tree method, then you can apply this tree method to any of the gate PYQ which is dealing with the conditional probability. Okay. So this is the actual diagram of the tree method, where I am saying, let's suppose the three events are happening, A1, A2, A3, and here B1, B2, or maybe B complement. Because see, if I'm writing something B1, B2, then I can always write it as B1, B1 complement, because if these are the two events, then if one of them is B or something, then another one will be the complement. If there are three events, then yeah, you can write A1, A2, A3. But if there are two events, then it is B and B complement. Or if you want, you can write B1, B2. But yeah, B and B complement also looks good. If these are the two events. Okay, these are the three events, and yeah, A1, A2, A3 you can write. Anyway, so let's suppose to start with, we have A1, A2, A3 options. Maybe you can say, for example, either I will watch movie, I will watch cricket, I will watch comedy, and then skip ad, not skip ad, like that. I mean, there could be any number of possibilities, but yeah, this is one of the tree diagram that you can have. Now here, as I just told you, the node probabilities, like if I just ask you what this node probability will be representing, it will be the probability of A1 intersection B. And what is this probability? Can you just write it down? This will be probability of B only, given that A1 has already occurred. And this is to start with probability of A1, right? So let's do one thing. Let's do couple of questions just to understand this tree diagram. Okay, so let me just call them concept questions. Okay, so let's just do this concept question just to understand this tree diagram. Cool. Now let's see what this particular question is asking. They are saying the probability X represent. So in this tree diagram, what do you think that what is the probability this X is representing? Just let me know the answer. Okay, so just pause this video and just answer this question like before answering me. So I think you got your answer. That answer is A, because here this is just the probability of A1, right? So let me see the answer. Yeah, this is the probability of A1. Very easy question and very nice answer also. So now let's just do the next question. What they're saying, what is the probability this Y is representing? Yeah, that's a good one. Can you answer this question? Just pause this video and just answer it. See here, it is the probability of B2 given that A1 has already happened, right? The probability of B2 given that A1 has already happened. Cool. Now, which means that C is the answer, right? Okay, C is the correct answer. Now let's just see the next question. The probability that Z represents, yeah, that's very, very nice. So what do you think? What is this probability? What is the probability that Z represents? Should it be the probability of C1 given that B2 has already occurred? Should it be C, or should it be probability of C1 given that A1 and B2 both has already occurred? What do you think? So here the answer is D. Like both has already occurred. You need to take all the cases in the process. So basically you need to consider all the events that has already occurred. So this particular node will represent the probability of C1 given that A1 and B1 has already occurred. Okay, actually this is like a reducing a domain. So basically, like once you say that A1 has occurred, then always after this point in time, always the given A1 will always be in the given side. After this point in time, always B2 is also in the given side. So basically it is just like a reducing the domain of reducing the sample space or something. I mean, you don't need to think about it, but yeah, I can just visualize in that fashion also. Okay. Now let's just see one last question related to this probability. So if I just ask you, what is this circled node representing? Then what do you think? This should be, first of all, it cannot be the conditional probability. It must be the joint probability or the multiplication probability, which means a comma or intersection. So what is this? This is A1, B2 and C1. C1. A1, B2 and C1. So C is the correct answer here, right? Yeah, C is the correct answer. So it cannot be conditional probability, first of all. So that's why D is anyway not the correct answer. Because this is the node probability, and node probabilities are the joint probability distribution or the multiplication probability. Okay. So these are called joint probability distribution, by the way. Okay, let's not worry about these terms, but yeah, these are called joint probability distribution. Now, let's just do one question which I have taken from MIT, and let's just try solving this question using the tree diagram. See, answer is on the next page, but I want you to solve this question. Just get the answer. If there is any problem, just comment it out. We will just answer it. Or maybe the answer is on the next page. You can take the hint out of it. Okay. So this is a very nice question to start with the tree diagram, and the answer is given on the next page. The question is taken from the MIT. Okay. So let's meet in the next video.